very long time. And that the warming in the climate system itself is unequivocal. There's no serious scientific debate over whether or not the Earth is actually warming. Likewise, the human influence on the climate system, particularly in the last century, is really quite clear. So that there's very little serious scientific debate that we are contributing to this phenomenon in really quite a substantial way, especially in the last 50 years, largely through the combustion of fossil fuels. If you then look to the future, the kinds of changes that we expect around the end of the century, which for some of us isn't quite as far off as it seemed to have been when we started this research, is likely to exceed another 1.5 degrees C, nearly 3 degrees Fahrenheit, relative to that 1850 timeline. For any emission scenario that IPCC looked at, and those include emission scenarios that embody quite aggressive mitigation actions, stable peaks and declines in emissions and stabilizations of atmospheric concentrations of greenhouse gases, and that in large part, because of this additional energy in the climate system, global sea level rise, as an average sea level rise, will continue to rise during the 21st century, and will even, in some cases, will accelerate during the 21st century. And that if we want to take the first of what was referred to as John Holdren's steps, that is to mitigate change, to reduce the emissions of greenhouse gases, that actually limiting this change in the physical climate system will require substantial and sustained reductions of greenhouse gas emissions. It's not enough to just cut emissions a little bit. Emissions will actually have to decline. They will effectively have to go to zero. And we will need to figure out how to get the energy we require for all of our societies with no net addition of greenhouse gases to the atmosphere. If you look at some of the underlying data, this is what the trends over the last, since the middle of the 19th century look like. And there are a couple of things I want you to notice about this. And one is that warming is really quite widespread. It's not, however, universal. It's not the same place in all. It's not the same in all places. There's a lot of geographic variability. There are some places that have warmed quite a lot. There are a few places that have actually cooled over the last half century. And this is not unexpected. This is, after all, simply the way the world works. That there's lots of regional variability, making the prediction or the forecasting for any particular place really quite difficult to do. If you then look at projections, and these are simply the outer reaches of the envelope, in a sense, the high projections from the high scenarios take us up to a very warm world indeed, something that we haven't seen in hundreds of thousands or even millions of years. Certainly at no time during the existence of humans on this planet have we seen a world that warm. And even the most aggressive mitigation scenario, stabilizing of atmospheric concentrations of greenhouse gases at relatively low levels, still results in a world that is warmer than the middle of the 19th century, warmer than the early 20th century, early 21st century, by the end of this century. So even aggressive actions reveal that there is some changes that we will not be able to avoid and that we therefore must prepare for. This is a similar graph for projections of sea level rise. IPCC is still, in many people's view, quite conservative with respect to sea level rise. It still does not include the effects of melting of landlocked ice or land-based ice in Greenland and West Antarctica, so it's largely looking at expansion of water simply due to heating. So, in conclusion, there are a few takeaway lessons that I think are important for this conference. And one is that the climate system itself, including sea level rise, has changed and is going to continue to change due to human influence. And even if we have rapid mitigation efforts with global consequence, it's not going to enable us to avoid all the adverse consequences. And so preparation and coping and building resilience into our various systems are going to be important as we respond to observed and as we plan for expected changes. The last thing that I want to leave you with then is this notion of time scale. A lot of these analyses that you see in the scientific literature show analysis of data from the past couple of centuries. We have projections that go out to 100 years. But for some people, these tend to leave the impression that change in the climate system and its impacts is something for our children to worry about or our grandchildren to worry about. But that's not true. We have impacts that are happening now in natural resources, in the built environment. We are experiencing the effects of a changed climate system every day in this country, and they are affecting how people live. Not to respond and not to plan and not to think about how the changed environment, the changed planet actually affects the way in which we live at this point is really not an option for us. Thank you.
Thank you. Again, cards will be circulating for you to note down questions. And online, obviously, you can use the information on Twitter or email. Our next speaker is Dr. Ben Strauss, who serves as the Vice President for Climate Impacts and Director of the Program on Sea Level Rise at Climate Central. He's published multiple scientific papers on sea level rise, testified before the U.S. Senate, led the development of SurgingSeas.org, coastal flood risk tool, and is now launching today a second generation of that tool, SurgingSeas.org.
Thank you so much, Andrew, and thank you to the organizers of this conference. It's a pleasure to be here. I'm trying to take a look at the controls of this computer. Let me, do you know?
Hit escape.
So let me get a couple things out of the way very quickly. First, today, business-wise, we have just released a new report on sea level rise and coastal flood risk in New Jersey. We've got a few copies here, New Jersey and the Surging Sea, and it's online, along with the release of our new sea level and coastal flood risk tool for New Jersey. You can find that via sealevel.climatecentral.org/ssrf/new.jersey. And, we have Internet Explorer. No, don't go there on the Internet Explorer, unless you have 10. Okay. Now we just need my screen to show up on that screen. Aha! So, we've also launched for New York today, but I'm going to click on New Jersey. And I'm going to show you a couple things quickly about this tool, but then really focus on one point that I want to drive home. Like many sea level tools, we've got maps. So we've got some problems with the resolution of this screen and the interface here, but invite you to come in and explore the map. You can zoom down, I'm not going to do it now, to the block level, neighborhood level. Take a look at the social vulnerability of neighborhoods, because when a natural catastrophe strikes, when a flood strikes, one part of it is the physical risk of the storm, but the other part of it is how prepared is a community, how able is a community to prepare for, respond to, and then recover from a natural catastrophe. So we're showing you the intersection of social vulnerability and this physical vulnerability to coastal flooding. So we've got the map. We've got analysis. Let's take a look here at New Jersey. So here's a map of the state, which shows by county what percentage of the population is below less than 5 feet above high tide line. By the way, Sandy reached 9 feet above the high tide line at the Battery in New York. It reached about 4.5 feet in Atlantic City and about 3.5 feet, actually closer to 4 feet, excuse me, in Atlantic City, and maybe 3.5, a little less than that at Cape May. So 5 feet is a pretty high flood line for most of New Jersey. So, you know, we've built an analysis on all kinds of variables. Property value, there are over $100 billion of property in New Jersey, less than 5 feet above the high tide line. There's the analysis. If you want, you can come and click in on one particular county. Here is Ocean County. And because of the kind of resolution, screen resolution interface issue, I'm just going to click on the all. We've analyzed over 100 different infrastructure variables and their vulnerability in New Jersey. And so I'm just going to scroll down through all of the tiles to give a sense. We've looked at schools, churches, roads, rail miles, airports, radio stations, hazardous waste sites that pose contamination risks, power plants, amount of land, you name it. So bottom line from all of that research, there's a lot of stuff on the coast. There's a lot of stuff that's really low, that's really vulnerable. You know, we're in New Jersey. We know, you already know this. We know this. Something else we learned that was quite interesting. Some of this exposure is extremely concentrated. So about 300,000 people live on land less than 5 feet above the high tide in New Jersey. 1/4 of them live in 3 zip codes. Atlantic City, Hoboken, and Wildwood. So, thinking about the future, it's possible that some really focused effort can help to protect against the next coastal flood. But the main thing I want to show and talk about, my last minute, is when is this all going to happen? How does the risk change? And most of the discussion of sea level rise is around graphs that look a little bit like this, okay? What's your sea level rise projection? This sea level rise projection happens to be right down the middle line of what the New York City panel on climate change recently projected in a June report. I think that projection is the best, latest state-of-the-art projection for this region that takes into account local factors, and you better believe that the New York City panel was highly motivated to do the best job that they could. So this graph shows really the center line, the mid-range of their projection. And you can see that, actually this is a projection adapted to the tide gauge in Atlantic City, that by the end of the century, maybe we get to 4 feet of sea level rise, which is not as high as the highest flood that Atlantic City has ever seen. It's a little higher than Cape May has seen. It's way lower than Sandy. 4 feet is really not, it's a kind of nasty flood in southern New Jersey, but it's not that bad. This is not the point of sea level rise. We get it all wrong when we talk about sea level rise projections, 1 foot, 2 foot. What we need to be worried about, okay, is how sea level rise multiplies flood risk. So now I'm going to show you the total flood risk of a flood up to 5 feet, which, by the way, is half a foot higher than the highest flood ever observed in more than a century in Atlantic City. And here's how the risk of that flood increases under the same sea level rise scenario. Okay? This is the cumulative risk. This is what I call sea level driving the coastal flood cliff, the coastal flood risk cliff. We can look at the annual risk, and it doesn't look quite as bad. But it's also a cliff. And imagine you bought a house this year, where I'm mousing over, and there's a 2% annual chance of a flood. Maybe that property has not seen a flood for decades, and you've got a 1 in 50-year chance of seeing a flood when you buy that. Now, by the end of your mortgage, it's flooding once every 3 years. Okay? That is sea level driving a coastal flood risk cliff. That is going to happen. The flood risk of extreme floods goes up much faster than sea level does. And so my question is, what is that going to do to real estate markets? What's that going to do to people's safety, to their lifetime savings if they invest in a home? And do you want to understand this before it happens?